Okay, welcome to the Singularity CE community call for March 2025 now. This will be recorded and posted on YouTube. So if you're watching this from the recording, hello, please feel free to drop any questions or things that you have um, after the call into the GitHub discussion thread or on the mailing list or anywhere else you can find us. This time round, we're mostly going to talk about the Singularity CE 4.3 release, which is coming up. So we've got a release candidate out now, and here are the release notes across on GitHub. And I'll just go through these relatively quickly, each point, and we'll look in depth at one of the features that's added with a bit of a demo. The 4.3.0 series has a few behavior changes, some bug fixes, some interesting new features, and we've also got one thing which has been removed from support. Let's look at the behavior changes first. These ones up the top, they're relatively small changes, and they're really around doing things which sort of make more sense. If a system is configured to bind all file systems from the host into a container, the administrator has set that option in the Singularity conf file. Then prior to this version, a failed attempt at binding a mount point into the container for whatever reason, maybe the mount is temporarily inaccessible on the host, something has gone a bit wrong there. A failed attempt would cause the container not to run. So there's a change here now when we're binding everything in from the host. It's sort of now a best effort. We'll get everything we can rather than fail if we don't get absolutely everything. The second and third points here are around C groups in OCI mode. So one of the aims for 4.3 on the roadmap was to streamline and kind of properly support and test nesting of containers. And with the OCI mode, we use the run C low-level runtime or C run low-level runtime to actually launch a fully OCI compatible container. And those low-level runtimes rely on manipulating C groups on systems that support that. So newer systems with C groups v2 and systemd set up to allow delegation so that non-root users can manage resource limits and things. So in 4.3, to support nesting with C groups properly, all OCI mode containers are now started in a C group when that's possible. And we create a C group namespace for those containers, which means inside the container, the C group hierarchy becomes rooted at the C group the container is running in. And then we mount the C group hierarchy inside the container. And what that does is let you look inside the container at the C group you're running in and any limits on resources that might be applied by it. And also, if you use the keep privs flag here, the C group hierarchy is mounted read-write in the container. And that's then allowing when you nest containers, run Singularity's OCI mode inside itself. It allows C group resource limits and things to be applied properly in a nested container. So those are the behavior changes. If we scroll down, we have some bug fixes. The first one is basically fixing an error in some circumstances which are quite unusual in the Singularity OCI command, which is not widely used. The second one is sort of more commonly applicable, Basically, when you use the Singularity instance command to start a container in the background, if it fails, we were writing the error messages out to the standard output instead of the standard error stream. So error messages should go to the error stream, and this fixes that. So if you're using instances in scripts and trying to catch any error output and so on, that tidies that up. There's a small fix related to debug messages with C groups which were inaccurate. Now, if you're pulling an OCI image into a CIF file, we skip setting any environment variables where the names of the environment variables are invalid. So it's possible, apparently, to create Docker images which try and set environment variables which just aren't valid to set in a shell. And someone had come across some of these images and they caused a failure when you pulled them using Singularity. So we now skip over those to avoid that issue. When you're building Singularity, you can now build it using a build directory, which is outside of where the source code is. That works properly. And the final thing here is another thing related to C groups and how we check whether they can be used or not. The exciting stuff then in the new features and functionality section, well, the first the first point here is related to the fake root mode. So in the fake root mode, when you run a container as a normal user and you're acting as a fake root user inside the container, the way we do that is by mapping your username to root in the context of a range of sub-UIDs and sub-GIDs, which an administrator has configured on the system. Until now, we've always directly looked for these mappings that have been set up in two files. So we've retrieved sub-IDs from the two files mentioned here. So this etc sub-ID and etc sub-GID file. And these are local files specific to an individual machine. They're a little cumbersome to kind of manage if you have a cluster or you have a load of machines across a network which all need the same settings and same accounts. So Red Hat, through their containers work, drove the kind of addition of support for storing these ID mappings elsewhere, like in an LDAP directory. And that's now present via something called libsubid and SSS. So SSS is a daemon which is used on enterprise Linux hosts, especially to cache and provide account information from different sources, be it local files or an LDAP directory or Active Directory or something else. And then libsubid is something which has been added to the shadow utilities so that you can retrieve sub-ID mappings from a source which isn't these local files. So Singularity now supports this, and by default, we'll build with support for this sub-ID. So it will follow whatever configuration is on the system to tell it where to get sub-ID mappings from. If you have a system which doesn't support libsubid, then you have to build Singularity now with a flag, which is mentioned down a little bit further, without libsubid. And then Singularity will directly read from these files rather than going through this libsubid library. The reason we need you to pass this without libsubid if you're not going to use it is because if you do have a system where an administrator has set up things to go through libsubid and get mappings from an LDAP directory, then directly using the files from a program like Singularity is kind of bypassing that configuration. So you end up with two separate places where ID mappings are. And it's possible that some people might want that, but it's unlikely. So we want to make sure that it's a definite choice to end up in that situation. And that's why we require that flag. Um, so other stuff, you can now sign, verify, push, and pull containers with cosign compatible signatures, and we're going to have a demo of that in a bit. So I won't touch on that too much yet. And the final point here on Red Hat systems, if you're building a container from a kind of low-level bootstrap of a distribution like CentOS Stream or Alma Linux, then you previously had to call the bootstrapper yum, but all these distributions have switched from yum to DNF now. So DNF is now available to specify in your definition file as a bootstrap source. And it's just an alias for yum. The bootstrapper behind the scenes knows to try DNF, and if it can't use DNF, it will fall back to trying to use yum. There are a few changes to the requirements for CE 4.3. So we now need Go version 1.23.4 or above. And that's because this is the version which is the minimum for some dependencies which we use. Mentioned before that you have to have libsubid headers or ask to compile specifically without libsubid support. The RPM packages we provide are built with libsubid support because it's all available in all of the current enterprise Linux versions. They're all set up so that you can configure to pull sub-IDs from an LDAP directory and so on. The Ubuntu dev packages, which we provide on the GitHub page, are built without libsubid support because older versions of Ubuntu don't have that option at all. And it's not sort of fully integrated as it is with Enterprise Linux on the newest version of Ubuntu. So that's why these packages don't have that support at present. The RPMs, the spec file to build an RPM, we've removed the portions of that which were relevant to SUSE Linux Enterprise Server and OpenSUSE because they've been untested and unsupported for some time. If anyone is interested in adding back support to build RPMs on SLES or OpenSUSE, we would appreciate any contribution where someone is also able to kind of maintain that over time as those distributions are upgraded and things change. We now support reproducible builds a bit better because the build ID that is embedded in the binary will now be derived from the Go build ID rather than us using a randomly generated one, which was a workaround from a long time ago due to how we mixed C and Go code. If you happen to use the Singularity OCI commands, and these are things which you can only run as root, and this is not the same as using the OCI mode. So this is if you use commands that say Singularity OCI, not commands which say --OCI, then you'll need to install the conmon package directly yourself. So we used to package conmon, bundle conmon with Singularity and build it as part of the install. But very few people use these Singularity OCI commands, which are really just for running an older style native CIF container in a sort of OCI lifecycle. As I mentioned, it's only available as root. It's not very flexible. Very few people use this, so we've dropped bundling and building conmon. If you need this, you'll have to install it yourself. And down at the bottom here, removed features Is just to note that the ability to write a plugin using a fake root callback, which was there to manipulate sub-ID mappings, has now been removed. The intention of this callback hook in the first place was that maybe someone could write their own plugin to pull ID mappings from LDAP or some other external source. Because we have that lib sub-ID support, we've removed that to simplify things so we don't get conflicts. And if you want to have custom sources for sub-IDs, then you can do that now through lib sub-ID and setting up things there. Okay, any questions at all on that? All right, so the packages are available for you to download and install and try the release candidate on your systems. The documentation has also been updated, and this has been rebuilt today, so that now if we go down to not the latest release version, which is 4.2, but the main branch guides, if you come across to the user guide here, or if you go to the admin guide, you'll find that this now includes the information about what's new in 4.3, and you'll have links off to updated portions of the guide where it's explaining the changes that we have. So what I'd like to do now, if there aren't any questions at this point, is jump into a quick demo of the cosign signature functionality. Now, cosign is a tool which is part of a project called SigStore. Okay, so the SigStore project defines ways of signing and verifying software artifacts, not necessarily just containers, but other things as well. And they define kind of standards and structures for doing that. And cosign is a tool associated with the project, which exists to sign and verify OCI containers, which are stored in an OCI registry. So the idea is that you can push a container you built with Docker or another OCI tool up into a registry, and you can sign it. And then anyone pulling that container to use it can verify the container before they use it. And this method, this tool, this cosign tool, has been gaining great adoption over some of the alternative ways of signing containers. It looks like it's probably going to be the dominant method for signing and verifying OCI containers as we move forward, becoming more popular than some of the specific methods which are built into Docker or have been in the Red Hat OS and Podman in the past, and the Notary tool, which was previously one which was recommended. So cosign, which I've run here, works against OCI containers in a registry. What it doesn't do is allow you to sign OCI containers in a CIF file, because the OCI CIF format that we have for Singularity, it's sort of custom to us. While we now store an OCI container in an OCI CIF file using the standard manifest, config, and layers structures, most tools still don't understand how to work with OCI CIF files. So what we've done in 4.3 is added the ability to go and sign an OCI CIF image which contains an OCI container with a signature that is compatible with the cosign tool. So we're going to be able to add a signature to the OCI CIF file, which looks just like a cosign signature would if it was in a registry. And because of this, and because of the way we already have interoperability with OCI registries, we could be able to push and pull signatures and verify them, not just with Singularity down in an OCI CIF file, but with the cosign tool itself up in a registry. So I have now an OCI CIF file here with a Alpine image in it. And the first thing I need to do to get started with cosign signatures is to create a key pair. So there's a new subcommand for the Singularity key command called generate cosign key pair. And if I run this, it will ask me for a password to protect the private key. So I'm putting in, oh, I'll try again. Putting in the same password twice there. And then it's generated for me a private key and a public key. So these are different than the PGP keys, which Singularity's native CIF signing uses. This will actually be an ECDSA, an elliptic curve key, and it's the type of thing. It's closer to what you'd see if you look at your SSH keys and so on. So once we've got a key pair, what we can do is go ahead and ask Singularity to sign our OCI image. So here, I've used Singularity sign like I would against any CIF file, but I've used the cosign flag, and I've provided my private key with the key flag. It's asked me for the password, which I use to protect the private key. And now that signature has been created and added to the file. We don't see much else, but if we kind of take a low-level look at the CIF file, here what I'm doing, I'm dumping the 7th descriptor from the CIF file. This is the root index of the OCI CIF, which kind of lists what OCI manifest, what things are in the OCI CIF file. And we'll see that in this manifest structure, here's my original container image, my Alpine image with this digest. And below it, I now see something else which says it's an OCI image, but it has some annotation here. And we'll see that rather than being a container image which we can execute, this is actually our signature in the form of an OCI image structure. That's how cosign stores things. And it's associated with the original container image using the digest. So we see here there's a ref name field, and it says this is a cosign signature for this container. So that matches that. That's not really important for day-to-day use. It's just pointing out that the cosign signature is technically another OCI image, albeit not an executable container. It's actually storing the signature for our container image in that type of structure. If we have a signed container, we can verify the container with Singularity verify. And again, we pass the cosign flag. And this time I'm passing the Singularity cosign.pub file, my public key. And I'm going to pipe the output here into JQ, and we'll see why when I run this command. What's happened is it's gone away. And first of all, it's made sure that the digests for every blob, every kind of entity stored in the OCI CIF file are correct. They match the metadata area of the CIF file. And then it's gone and found that there's an executable container image in the file with this hash, and it's dug out the associated signature. So it's found one, and then it's doing the actual cryptographic validation of the signature. And what we get reported is that there's one signature here that's valid with the provided key material. This portion of JSON, which is spit out at the end, this is the payload of the cosine signature. So if you look at a cosine signature created with another tool, the SigStore's cosine tool, against a standard OCI image, you'd see a similar thing. What we have is a kind of link to the image by its digest. It tells us it's a cosine image signature. And in this case, we have some optional stuff. We just record who created it. So you can see Singularity created this signature rather than another tool. And there's the timestamp from when it was created. So there we go. We have now a signed image, which we can verify. But instead of a CIF signature, which is over the data and metadata in a CIF file, what we have is a cosine signature, which is against the image inside the CIF file, rather than the sort of structure and raw data of the CIF file itself. That's important because the fact that the signature is against the OCI image and not the CIF file means that when we move images to and fro, up to and down from an OCI registry, we can bring the signature along because it's relevant to the image. We don't have a CIF file anymore, but we do still have an image and a signature which goes with that image. If you have a different key, and here, this is a key which we did not sign the file with, and I try and verify with that, what we'll see is that we get an error out at the bottom here. We found that there's one signature on the image, but no signatures are valid with the key material, so we have an error that no valid signatures were found. You can apply multiple signatures onto an OCI CIF image. You can use different keys, but you can only verify at present using one key at a time. So if you sign with multiple keys to indicate different things, you would have to verify multiple times once with each key in order to check that it was signed with more than one valid key. Let's have a very quick demo then of what happens when you go and push this signed image up to a registry. What I can do is grab a command out of the documentation I have, and I just change it here so it's going to go up to my actual Docker Hub account. I'm pushing with cosine, which is telling it to take the signatures along as well, from my Alpine OCI CIF file up to a repository at Docker Hub. When I run that, what we'll see is that as well as pushing the image and uploading it, it informs us that it's writing a cosine signature there. And then what I can do, because this image is up in the OCI registry as an OCI image, I can actually use the SigStore project's own cosine tool here to verify that signature. So what I'm doing is saying cosine verify, and I'm using my public key that I created, and I'm pointing it at this repository up on Docker Hub. And if I run that, I see that the same signature I saw before when I used Singularity Verify is there, and it's present, and it's valid against this image, which is now up on Docker Hub. I could also pull this image down to a CIF, again with the with cosine flag to bring the signature along with it. If you're looking carefully, you might have noticed there's a scary looking flag on this cosine command, which says insecure ignore tlog. Now, what this is about is something called a transparency log. So the SigStore project has not just tools for signing, but they also have tools for maintaining a transparency log where you basically publish signing events. So there's a public record that something was signed by a certain identity at a certain time. And the version 2 of the cosign tool expects everything to be present with a record in the public transparency log, the default one, unless you tell it otherwise. So here we've got a flag which says insecure ignore tlog, which is just telling it not to look for a record in the transparency log when it's verifying the signature. The fact that there's no record in the transparency log doesn't invalidate the signature or make the signature insecure, but the SigStore project has made a conscious decision that the additional security of having a public transparency log which records signing events so that you are able to see when it was signed and the identity and their timestamps on that is something that should be a default. Singularity won't currently write into a transparency log. That's something that could be added in the future, but at present you need to either say verify insecure ignore tlog, or the alternative, which perhaps looks a little less scary and makes more sense if you think, oh, well, I'm doing everything in private. I don't really want things going up into a public transparency log. There's another flag called private infrastructure, and this actually has the same effect. And really that's just there because people who manage their own key infrastructure and so on and don't want things in a public transparency log can use this, and it's not as scary or misleading perhaps as saying that it's completely insecure to ignore the transparency log. Anyway, that's a quick demo of this cosign signing, which we have in 4.3. Does anyone have any questions or any thoughts about
that? Do you have an anticipated date for a 4.3 release, like the full release?
It's likely that the 4.3 full release will take place next week or a week after, depending on if anyone finds anything that needs fixing. So the plan is to do it next Thursday or the Thursday after that, if there's anything that needs to be fixed.
Cheers. Thanks.
All right, I've just talked quite a lot about various complicated or not so complicated things. So you come to the final point as usual. Any general discussion or any questions anyone has about Singularity or the ongoing development or the new features, that's all. If there is nothing, we'll say goodbye till next time. If you do think of anything that you want to ask about after you've left the call or you've seen this on YouTube, the best place to ask is probably on the discussion thread on the GitHub repository. If you sign in here, you can ask and it's directly against this call. Otherwise, you can find us on Slack or the other usual places where we hang out. So thanks for coming, and I will see you next time.